So here we're going to do the mean value theorem. Another big theorem here. So we've talked about some big theorems in calculus so far. We talked about the intermediate value theorem. So the intermediate value theorem says if I've got some continuous curve and this function, that if I have some y value down here and some y value up here, then at some point between these x values there exists some c in the middle at which we cross some particular line, whatever that line is set, that's between these two values there. That's the intermediate value theorem. Let's see. Besides the intermediate value theorem, we had the extreme value theorem was another one, and that extreme value theorem said if I had some continuous function on a closed interval, then at some point there has to be some absolute max and some absolute min, okay? And so this last one here, this last big theorem, is the mean value theorem, and it's kind of based on this question right here, all right? So suppose you travel 30 miles from here to NAC in 23 minutes. Okay, so you're traveling 30 miles from Lufkin to Nacogdoches, and it takes you 23 minutes. The question becomes, did you break the 75 mile per hour speed limit? Okay, did you go faster than that? All right, that's the question. Well, how do we figure out speed? Miles per hour, right? So first thing we need to do is we need to convert 23 minutes to units and hours. Well, there are 60 minutes in 1 hour. So if I take 23 and divide by 60, that's how many hours it is. Okay, so that's my units and hours. Now I have my miles, so miles per hour. So I take 30 divided by my 23 over 60, so 30 miles per hour. Okay, and then whenever I do this arithmetic, I get 78.26. Now, miles per hour here was calculated through averaging. The average speed that we traveled from Lufkin to Nacogdoches at 30 miles, it took us 23 minutes. The average speed was 78 miles per hour. So the question is, did we break the speed limit? Did we break the 75 mile per hour speed limit? And I think common sense would tell us is if we traveled an average of 78 miles per hour, then yeah, we definitely, at some point, we're going faster than the 75 mile per hour speed limit, okay? So this is proven mathematically through the mean value theorem. So something that's common sense is proven mathematically through the mean value theorem. So let's talk about the mean value theorem for differentiation. So here's the hypothesis, okay? The hypothesis, if the hypothesis is true, then the conclusion will follow. So here's what we have to assume to be true. Number one, f needs to be continuous, okay? So very similar setup to the extreme value theorem and the intermediate value theorem. With the mean value theorem, we need f to be continuous on a closed interval a to b, okay? Very similar to the other two big theorems. Number two, we need to add differentiability, okay? So f is differentiable. Not only is it continuous, it's smooth, okay? No sharp turns, undefined derivatives, whatever, okay? It's differentiable on the open interval a to b. Why? Because, if we don't use that extended definition, we know that it's differentiable. You can only be differentiable on an open interval because remember, we're taking that limit, right? So when we think about the idea of a limit, we need to be on both sides, the left and right side. That's why we deal with an open interval for differentiability, okay? All right, so if those two things are true, what the graph would look like is something like this. It's smooth for differentiability, and it's continuous. I can draw it without picking up my pen, and on a closed interval, there's no open circles at the end of my graphs, okay, from A to B. Now, the conclusion is this for the mean value theorem. There exists at least one number. Okay, that one number is C. So there's some C between A and B such that if I plug C into my function, I get out f of C, right? Well, f prime, the derivative of the function, so not the actual function, but the derivative, evaluated at that special number C, is equal to, this is the instantaneous velocity, that's the slope of the tangent line. What does the tangent line here look like? It's this line right there. So that number is equal to, well, the secant line, the slope of the secant line. Say I have a point A. When I plug in A, it outputs f of A. And a point B, when I plug in B, it outputs f of B. Okay, so how do I find the slope between those two dots there, those two endpoints? Well, I take y2 minus y1 over x2 minus x1. Okay, so I'm going to do f of B minus f of A divided by B minus A. y2 minus y1 over x2 minus x1. Okay, if these are x1, y1, x2, y2, right? So what does that represent? This is the average velocity. So this is the slope between those 2 points right here. So when I draw the picture, it looks like this. And what do you notice from the picture? What this is saying is there's at least one point C that has the same exact slope as the secant line that passes through here. Now, is that the only C possible? Is that the only place? Well, it looks like with this graph, you might actually have another C. So what we're saying here is not only is there guaranteed to be one C number, but there is at least one C number. And at least one means there could be more than one, okay? So for here, I just wrote down one of them, but I'm just illustrating that to let you see that you could have more than one time that you have a different C that produces another average slope that's the same slope as the endpoints produce, okay? So in our little example that I was using here with the traveling, what this is saying is that if I took 23 minutes to travel 30 miles, if my secant line was 78 miles per hour slope, like say this was the 78 mile per hour slope here, okay? What this is saying is at least one point in my trip, I had to go exactly 78.26 miles per hour. And I did it right here. But what this graph shows me is that I also did it in another spot too. So not just once, but twice. But the mean value theorem guarantees at least one time. Okay, so it's not always the case that you have twice like this picture shows, but you for sure have at least once. So this is the slope of the secant line, which is going through right there. Okay, so pretty cool stuff. So if your average speed, once again, is 78 miles per hour, then at some point on the trip, the cop could mathematically say that you were going 78 miles per hour by the mean value theorem. And this is how they can prove without ever seeing it, that they can mathematically say this person was speeding between Lufkin and Nacogdoches because they got to Nacogdoches. Maybe they have traffic cameras that spot them at Lufkin, and then 23 minutes later they have a traffic camera that spots them in Nac. And they say, look, there's no way that they could have got from Lufkin to Nac without going at least 78 miles per hour at one point during the trip. Therefore, they broke the speed limit, right? Now, if you get pulled over for going a couple miles over speed limit, maybe that's a little fishy, right? Okay, so the mean value theorem is an existence theorem, okay? So what do I mean by that? The mean value theorem does not tell us what the C value is. All it does is guarantee us that there's some C between A and B, such that if I plug in C for its derivative, it equals to the slope of the secant line. Okay, so it's an existence theorem. It doesn't tell us what the C is. It just guarantees you that there's a C between A and B such that it exists. So it doesn't tell us how to find C. All it does is it just says that that C exists. Okay? So that's where we'll leave it, and then we'll talk about another kind of important theorem in another video.